Dear faculty members, research scholars, and PG students, welcome to my channel. In this video, I am going to discuss how to write the proposed method section part 2. It is continuation of part 1. Previously, we discussed how to write the first subsection, that is a base model of our proposed method. In this video, particularly, I am going to explain in detail how to write the second subsection of the proposed method, that is how to find existing methods and how to do implementation. Already we have these steps in my previous video. I discussed these steps. Today in this video we are going to discuss step number 2, 3 and 4, that is collection of existing models or methods that should be related to our proposed method. Third one is implementation platform, and finally implementation. So always we should remember this table, because while writing the proposed method section, we have to remember this table. The experiment is related to reading and understanding. Implementation will be the output. And the results point of view, data set is the input, and output will be findings or significance. Finally, justification. The justification input will be selection of variables, and the output will be changes on variables. Because in the proposed method, these three elements will be playing a vital role: experiment, results, and justification of the proposed method. So that I am again explaining this table here. Already we know this is the base model. I discussed in my previous video anisotropic division method for denoising, image denoising. So this is the base equation, the traditional anisotropic diffusion. Perona Malik is the inventors. So anisotropic diffusion, and they are using these two equations, either first one or the second equation. Okay. So this is the base model. I am going to collect related to this base model, because already authors are modifying or altered or incorporated any statistical manner in the particular equation. So based on our literature, we have to select the related anisotropic division method, because these method will be utilized in the comparison purpose. So that in the proposed system, the first subsection we are introducing the traditional method. In the second section, we are going to introduce the existing related method, that is related to anisotropic diffusion. Because with the proposed method, we are going to compare with the existing methods. So here I am. The second step is collection of existing models or methods. Method 1 here I am showing. Here note down. So they are modified one part in the equation. You compare. You can see this. This is the equation, and they are modified this equation k of 0 t to the power of minus 1 by 3. So this is one kind of modification, that is where k0 is the average gradient magnitude. So average gradient magnitude is incorporated in the particular equation, and accordingly they will achieve the proposed method or results. That is, this paper is obtained, this equation is obtained this paper. So actually, for example, I am using here a very old paper 2005, and another paper is 2006, but you have to take at least less than 3 years, between the 3 years. For example, if you are proposing method 2020, you have to collect 2018 2019 purpose for comparison purpose. In the method 2 also they are incorporating, that is a local variance, that is sigma square, as a weightage. Okay, so see, this is the equation k, this is the equation k, and accordingly they are adding, that is giving weightage sigma square here, and it will be reflect in the output also. So like that, the small modification done by the previous existing method, and we can choose for comparison purpose. And the sigma local variances has been calculated using this equation. So here I am giving method 1, method 2 for example purpose. So like that you can choose minimum 4 methods, that is existing methods. So already we have a traditional method. Apart from traditional method, we have to select 4 methods. So 5 methods can be utilized, can be used for comparison with our proposed method. And implementation. So how to implement these equations? So already I told you we have to focus each and every variable of the each equation and step by step, and you have to understand the paper article also. So we have to read and understand, then only we can implement as per our table. We have to understand the paper. And the implementation, choosing the implementation platform. So I am suggesting these platforms. So as per your comfort level, you can implement anything. Why I am choosing this platform is, that is Microsoft Visual Basic, C Sharp, etc. Visual Studio. So any tool you can use, MATLAB, Python. So why I am suggesting this is, so we can modify easily. I am giving one example here, how we are going to modify here. So this is the same anisotropic division code for in the VB.NET. Okay. So initially the iteration, we need to get the iteration number of iteration threshold k value, and accordingly I am moving each and every pixel of the image using for loop. This is the first for loop is iteration. So delta, initially I am finding the delta north, south, east, west, because the previously the equation was the 4 equation, that is x plus 1. The previous video I explained this one, and accordingly we can calculate the Cn Cs using this the math power of. So I am using this equation, that is 1 by 1 plus this equation. So 1 by 1 plus that is delta divided by k whole square. So this equation will be implemented here, and this is the final equation, I equal to Pm of, there is array delta Cn delta, that is this equation. So this equation so can be implemented like this. So why I am telling this, explaining this implementation is, while implementing step by step, you can understand each and every process inside the particular base model or the proposed or the existing models, any modified models. So accordingly, we can incorporate any mathematically, that is a statistical manner, in the particular line or particular section of the code, so that we have to elaborately write in the uh, chosen platform, so that the VB.NET and the MATLAB coding here also elaborately I am writing this, how to that is implementing the anisotropic division, the same idea but the syntax is different. So here we can incorporate any statistical variables or equations in the particular section. For example, why not directly we should not use function, means already we have a IM diffuse filter in the MATLAB. It is anisotropic, it is already built-in function. We don't know how many iterations inside, we don't know the k value, but there inside the function they described it. But we can't modify the that is as we required, so that we need to implement step by step based on the equation. I hope you understand. So from the base model you have to implement each and every equation, so accordingly you can map with your specialized domain. It will be useful for the proposed method also. So after that implementing our base model and existing methods, so we can write the second subsection of the proposed method. Here we elaborately we can write the existing method and the mathematical steps in the existing method also for future comparisons. So in the next video, we are going to discuss how to propose our proposed model in terms of mathematical or statistical manner, and how to analyze, how to justify our proposed method in terms of performance. Thanks for watching my channel. Subscribe my channel, like and share my videos. Press the bell icon for your notification. Thank you.